Hello friends, I Praveen Chobe welcome you all to this session. Today I am going to talk about the methods to solve ordinary differential equations. In today's session I am going to cover modified Euler's method for solving the ordinary differential equations. To understand this method, you must have some knowledge of numerical methods and you must be at least aware of what is Euler's method, because this is the second version of Euler's formula, that is modified Euler's formula or modified Euler's method. So let us start with the method very quickly. In this method we will be starting first of all with a first formula that is called predictor formula. This is a formula which is directly taken from Euler's method. So first is predictor formula, and as the word suggests, predictor, this formula is mainly used to predict the value of y with respect to x. When some value of x you have got, then with respect to that value, how to predict the value of y. That is how we need to understand out of it. That is what we need to understand out of it. So the formula for finding out the value of y, new value of y when we are calculating, that is say y1. y1 is equals to y0 plus h into f of x0 y0. Now to understand this, what all these terms are, y is new value of y, y1 is new value of y, y0 is previous value which must be given to you in the numerical itself. Then h, which is present here, h is standing for step size, h is called step size, and f of x0 y0 is the value of f of xy at x is equals to x0 and y is equals to y0. That's what we need to understand out of this. So if you look at the formula, the generalized formula for this predictor method or predictor formula for Euler's method, moreover I can say, is yn is equals to yn minus 1 plus h into f of x minus 1 f of x n minus 1 yn minus 1. Now this formula, with the help of this formula, this is a generalized formula as I said. With the help of this formula, if I am calculating y1, that becomes y 1 minus 1 becomes 0, so y0 plus h into f of, in bracket, x n minus 1 means 0, 1 minus 1 comma y0, and that is how the previous formula which was shown was derived. So friends, this is a very basic formula. I hope everyone will understand this. New value of y, that is y1, is equals to y0, that is initial value of y, plus h is a step size, into f of x0 y0, where, as I said, the step size h is equals to xr minus x0 divided by n, where this n is standing for number of iterations. N is representing number of iterations which is mentioned here, say 0, 1, 2, 3 up to n. So n is standing for number of iterations here. xr is, you can say, the value of r, that is new value of r, and x0 is initial value of r. So final value or say new value of r, final value or new value of x minus initial value of x divided by number of iterations. This is the value for step size h. That is how we'll understand how to calculate the step size. Apart from that, in some of the numericals you may find that on these methods you may find that n value you are supposed to calculate and h value is already given in the problem. So n, which is nothing but number of iterations, how many iterations are to be taken, that value we are calculating from the same formula as xr, that is new value or final value of x, minus x0 initial value divided by h. H will be the step size. So I hope you understood what I am saying. Then this formula predicts the value of y. What this formula does, this formula predicts the value of y, and that is why This is called predictor formula. We said this is a formula which is coming from Euler's method, or this is also called predictor formula. Then there is one more formula that is called corrector formula. What we did here is, with the help of this formula, that is predictor formula, we have predicted that y will be having some value. Say you might have got some answer 0.2356 likewise. This is just for an example. So if you got this value, say y1, then this was just the prediction as we have calculated this from predictor formula. Then this can be corrected this value can be corrected with the help of corrector formula. What that corrector formula says, or what that corrector formula is giving us, is, you will understand from this corrector formula. This formula is used to correct the value of y1 with respect to accuracy. This is iterative or recursive, meaning of which we will understand. We could take n number of iterations. When you are using this formula, you may take n number of iterations. That number of iterations can be calculated, that is n. So this formula mainly is used to correct the value of y which is calculated from predictor formula. When you have predicted some value that y should be this much, and no doubt value of y is dependent on value of x. That also you need to remember. Value of y is dependent on value of x, which is shown here with the help of this equation. And once you calculate that value of y, that value may not be correct, that as it is just predicted value, then that can be corrected with respect to the accuracy. With respect to accuracy which is mentioned, it must be given to you that this much will be the accuracy for calculation. So that accuracy is taken into account in order to correct the value of y. How to do that? Let us see. So this formula states that, corrective formula for Euler's modified method states that y1 of 1, I will call this as y1 of 1, or y1 raised to power 1, is equals to what? Y0. This is equals to y0 plus h by 2 in bracket f of x0 y0, comma f of x0 y f of x1 y1 raised to 0. Generally, you may not have understood what I said just now. Generally, this formula should be, generally it is given by yn raised to power k is equals to yn minus 1 plus h by 2 f of xn minus 1 yn minus 1, comma f of xn yn k minus 1. Now, what we did here is, we are trying to correct the value of y. See, if you observe this, I have taken, say, for this example, y1 value I have calculated in this example, right, in this formula. So that y1 value only I am trying to correct now with the value which I have predicted from previous formula, that I am trying to correct y1 value. And that y1 value can be corrected with n number of iterations. So first iteration when I am taking, I will call this as y1 raised to 1. Then it becomes y1 raised to 2 in second iteration, y1 raised to 3 and y1 raised to n. So likewise, I have written here yn means nth value of y raised to power k, that is kth iteration for calculating the corrected value for correction, is equals to what? The formula is yn minus 1. The formula is yn minus 1, which is shown here. Yn raised to power k is equals to yn minus 1 plus h by 2 into f of xn minus 1, comma yn minus 1, comma f of xn, comma yn raised to power k minus 1. Now this you may not understand very easily, but while solving the problem, I am confident you will definitely understand what I just now said or what is written. Here n, we have considered n as number of iterations. So n can be starting from 0, 1, 2, 3 up to n, and k is also, we are considering this as iteration number to correct the value of y, that is yn plus 1. So this k, which is represented here in raised to the power, that is considered as the iteration number to correct the value of y, while n is actually the iteration number of iterations required here to calculate the value of y. So these two steps are different, but in the problem I'm damn confident you will understand everything which I just now said. Okay, so let us start with the problem. First problem I will be taking. So in the first problem statement itself, what is given? You have to solve the following differential equation using modified Euler's formula. So the method which we are supposed to use, that is mentioned here. Modified Euler's method we are supposed to use. What we are supposed to solve for? See, problem statement once again I will go through. Solve the following differential equation using modified Euler's method for dy by dx is equals to square root of x plus y and f of 1 is equals to 2.2. Find yr for xr is equals to 1.2. See, all this is the information which we are going to use further. Okay, so I will finish this statement, then we'll try to understand what is given. Correct up to accuracy 0.0001. This much accuracy is given. See, very high accuracy is given. So number of iterations are also mentioned here. Number of iterations are also mentioned, that is I think 2. Number of iteration is also mentioned, that is 2, that we are going to calculate once again also. Okay, so in the problem statement what I have understood first of all is see, I have understood few things. The equation which is given to me is dy by dx is equals to square root of x plus y. This is the equation given. Now if I look at this equation, I will find x term there, I will find y term there. So I can say this is f of x comma y. It means the given equation is the equation which is function of x and y. First thing I have understood. Second thing, as it is the equation of dy by dx is equals to, I will say this is a differential equation. Moreover, this is a ordinary differential equation. Ordinary differential equation. If I go more specifically, I can say this is first order ODE, because I have the term dy by dx here. If I would have the term, if in the equation the term you must have, or the term which is present in the equation is say d2x by dy square. Likewise, if the term is there, then I can say this is second order. Or moreover, if d square y by dx square such term is there, then this is a second order equation. So I have understood from the given equation that this is a first order equation as dy by dx term is there, and I'm supposed to use modified Euler's method for it. Few more things. One of the interesting formula, or one of the interesting thing which is given here, f of 1 is equals to 2.2. This type of statement you are going to get in almost every problem. On ordinary differential equation. This equation has to be always compared with f of x0 is equals to y0. Always you are, as it is initial value given, as this value is already given in the problem, so I will consider this as initial value, and that is why instead of x and y I have taken x0 and y0 in order to understand this is starting value, this is initial value. So from this equation I could say that x0 is equals to 1 and y0 is equals to 2.2. So same thing is mentioned here. See, dy by dx is equals to f of xy, and which is equals to square root of x plus y. F of 1 is equals to 0. If I compare it with f of x0 is equals to, f of 1 is equals to 2.2. If I compare it with f of x0 with equals to y0, then I will get x0 is equals to 1, y0 is equals to 2.2. Accuracy which is given is 0.0001. This is the accuracy given, and number of iterations, it is also given in the problem that number of iterations is equals to 2. So if number of iterations are given in the problem, then the next work is to first of all find out the step size, which is h. H is equals to what? xr minus x0 upon n. This is the formula for calculating the step size, out of which xr is what? It is given in the problem that you need to find the value of y at x is equals to 1.2. So 1.2 is nothing but the value of xr. In this problem it is specifically mentioned that you have to find out yr at xr is equals to 1.2. Sometimes this yr and xr is not given, still it is stated that you have to find the value of y at x is equals to 1.2. In that case you need to understand you are supposed to find out yr and xr value is 1.2. So I have got the value of xr, I have got the value for x0, I have got the value for n, then I could calculate h. So h can be calculated as 1.2 minus 1 divided by 2, that becomes 0.1. So 0.1 will be the step size. With the help of this step size I am going to use modified Euler's method to solve this ordinary differential equation. Okay, so let us see how to do that. So first of all we'll be using the predictor's formula. As we know, there are two formulas. So firstly we are trying to use the predictor's formula. So in this predictor's formula I have written, say, iteration number 1, n is equals to 1 I have taken, iteration 1. Step 1 is to predict the value of y1, and it is predicted with the formula of yn, which is given by yn is equals to yn minus 1 plus h into f of xn minus 1 yn minus 1, which is a generalized formula. If I write this formula for first iteration, means if I take n is equals to 1 in this formula, I could say y1 is equals to yn minus 1 means 0, 1 minus 1 becomes 0, plus h into f of x0 comma y0. Now this f of x0 comma y0, you need to understand, whenever we say f of x0 comma y0, what is this? This is nothing but value of f of xy, f of x comma y at x is equals to x0 and y is equals to y0. x0 and y0, these values are given in the problem. So what does it means? It means in the equation of f of xy, you need to put x is equals to x0, y is equals to y0. For this problem, that value will be x0 is equals to 1 and y0 is equals to 2.2, which is shown here. Okay, so predictor's formula, let us come back to this discussion. Predictor's formula becomes here y1 is equals to, predictor's formula, y1 is equals to, I can say what, y0 plus h into f of x0 y0. And from where this formula is taken? This is taken from this point. I hope you understood this. Okay, so from this only this formula is derived. So I have got y1 is equals to y0 plus h into f of x0 y0. Now what is f of xy? F of xy, x comma y in this equation, is square root of x0, is square root of x plus y, right? So if I want f of x0 y0, I need to make this as x0 y0. Hope you have understood this, what changes I have made. Okay, so that is why this becomes, y1 becomes equals to, y0 is as it is, h is as it is. Instead of f of x0 y0, I have written the value of square root of x0 y0. Why it is done? Because f of x0 y0 is nothing but square root of x0 y0. And from where I have got this? I have got this from this equation, that is dy by dx, which is the function of f of xy is equals to square root of x plus y. So I hope you understood this, friend. Now in this equation I am going to put the values. Which values I am going to put? I am going to put the value of y0, which is 2.2, then h 0.1, then x0 is 1 and y0 is 2.2. So if you put all those values, then we'll get y1 is equals to this much. Y1 is equals to how much? Y1 is equals to, you will get 2.3788854 38. This much is the value we'll get here for y1. The moment we got the value of y1, our work is to calculate the value of x1. Our work is to calculate the value of x1 because x1 and y1 are the values those we are going to use in further iterations, in next iterations. Okay, so we'll be starting with that uh, calculation of x1. X1 generally is equals to x0 plus h. From where I have got this? This is from the formula of modified Euler's method. You can see the formula of modified Euler's method where xn is equals to xn minus 1 plus h. So I have got x1 is equals to x0 plus h. H is step size, no doubt everyone is knowing now. So x0 is initial value plus step size is added, so it becomes new value of x. So that is why x1 is equals to x0 plus h. If I put the value of x0 and h, I have got this equals to 1.1. Now if it is equals to 1.1, then further stage is to correct the value of y. To correct the value of y, what I need to do is, first thing what I did is I have completed my first iteration here. First iteration is completed here. This is first iteration. Okay, at the end of first iteration I have got some value of y, that is y1 is equals to this much I have got. Now my work is to correct this value of y1, right? So to correct that value I am going for step 2, that is correct the value of y1, that is using the corrective formula. Okay, so for correction I am taking first iteration for correction. First one was first iteration, if you look at here, that was for prediction, that was for predicting the value of y. Now I am going to correct the value of y. When we are correcting the value, iteration is represented with k. When we are predicting the value, the equation is the iteration is represented with n, right? So when I am correcting the value, I will start with the first equation, generalized equation, yn raised to k is equals to yn minus 1 plus h by 2 f of xn minus 1 yn minus 1 plus f of xn comma yn raised to power k minus 1. This is the important formula everyone need to remember. This is important and generalized formula, everyone needs to be remember this. Okay, so this formula here for this case, this was the generalized formula. For this case where we have just calculated the value of y1 and we are taking the first iteration for correction, this becomes y1 raised to 1 is equals to yn minus 1 means n is equals to 1 is 1 you have to consider, so yn minus 1 becomes y0 plus h by 2 will be as it is into, after h by 2 into f of x0 y0 plus f of x1 y1 raised to power 0. K minus 1 means 0, k is equals to 1 here, that is why it is equals to 0. I hope you understood how this formula is written. So that is why y1 raised to power 1 becomes equals to, from where I am writing this, I am writing this from this formula, generalized formula only, yn raised to power k. Here k is iteration for correction, so this is first iteration, hence it becomes y raised to 1. N is the first iteration which was completed, that is why this was also 1 here, right? Hence y1 raised to power 1 becomes equals to what? y0 plus h by 2 into f of x0 y0 plus f of x1 y1 raised to power 0. And if I put those values, what I will get is, I know y1 raised to power 1 is equals to y0 plus h by 2 in bracket. What is that? In bracket the term is, see, the term is square root of x0 plus y0. Now from where this term has came? This is again came from the equation which is given. See, the equation given is f of xy is equals to square root of x plus y. This was the equation given in the problem. So if I am replacing it with x0 y0, this becomes x0 y0, right? And hence we could say the equation which is mentioned here has become this: y1 raised to power 1 is equals to y0 plus h by 2 in bracket square root of x0 plus y0 plus square root of x1 plus y1 raised to power 0. Okay. Now, if we put the values, we know y0 is equals to 2.2, h is equals to 0.1, x0 is 1, y0 is 2.2, then x1 is 1.1, x1 raised to power 0. This value we have just now calculated, where it is this value I am going to take. This is the value of y1, right? This is the value of y1. This is the first value of y1 which was known to us. That value I am going to take here itself. So that same value is taken as it is, and I have called this as y1 0. What does it means? It is value of y after first iteration and when there was no correction. This 0 is representing that there was no correction. When I am making the iteration for first correction, this has become 1. When I am going to make the second iteration for correction, this is going to become, raised to power is going to become 2. So here there was no correction, that is why this value was y1 raised to power 0. Hope everyone will understand this. Okay. So if I calculate this, I will get y1 raised to power 1 is equals to y1 raised to power 1 is equals to 2.38135. 2.38135. This is the value of y1 of 1, right? Now this value, why I did this is to correct the value of y1 value was already calculated and now I am trying to correct that. So I have corrected the value, and after correction this was the value. So if this is the value after correction, I am going to check now how much accuracy I have got. And how to check that? To check the accuracy, what I am going to do is I am going to take the value of y after correction, that is y1 raised to power 1, minus value of y before correction. So magnitude part, definitely, as it is mentioned in the problem that you must have the accuracy 0.0001. So I need to check whether that accuracy is achieved or not. So in order to achieve that, I need to take step 3, that is here. Step 3. What I did in step 3 is magnitude of y1 after correction minus magnitude of y1 before correction, and its difference I am going to check, and that difference is coming to be 0.00247, which is definitely greater than 0.0001, as 0.001 is the accuracy which is mentioned in the problem. So hence what I need to do is I need to understand that the accuracy which is needed is not achieved. If the accuracy is not achieved, what I need to do is, hence it is mentioned here, see, hence we need to take iteration 2, that is k is equals to 2. I am going for which iteration? Iteration for correction. Iteration for correction I am going to repeat. One more iteration I am going to take, because I need to have the accuracy below 0.0001. If that accuracy is achieved, then I would have moved for next correction, or then I would have moved for next iteration for prediction of new value of y. If the accuracy is less than the mentioned accuracy, then I need to take another iteration for correction. That's what we need to understand. Okay, so another iteration we are taking for correction, and we are calling this as iteration 2. Hence, as I understood, k is equals to 2 I have written, it means this is the iteration for correction. y1 value I have calculated at x is equals to some value, and that value is not correct yet. How it is not correct? Because it is not having, or it is not showing the accuracy, mentioned accuracy in the problem, that is 0.0001. That is why all these things I am doing. Okay, so second iteration again we start. In second iteration the formula becomes y1 raised to power 2. What does I understand out of it is, this is second iteration for correction of value of y1. y1 value I am going to correct second time. First time I have done it earlier where I have written this as 1. So this k has become equals to now 2. So y1 raised to power 2 is equals to, the formula is again same. This is going to become y0 plus h by 2 in bracket f of x0 y0 comma f of x1 y1 raised to power 1. Now see, that's the only difference in formula. If you look at the earlier formula and this one, the difference is very small in the iteration. When we are correcting the formula in the iteration formula, the difference is very small. See, what is the difference? That difference was here itself. See, this is the formula. y1 of 1 is equals to y0 h2 by 2 f of x0 y0 plus f of x1 y raised to power 0. This was y raised to power 0. Okay. Now, if I am taking the another iteration, that formula becomes the second iteration for correction. Formula becomes y1 raised to power 2 is equals to y0 by y0 remains as it is. Then no, sorry, here I need to mention y0 remains as it is, h by 2 remains as it is, f of x0 y0 remains as it is, f of x1 also remains as it is. Only instead of y1 raised to power 0, I need to take this as y1 raised to power 1, and that's the difference in the formula. So if you look at this formula, you will get it equals to y1 square is equals to y0 is as it is, h by 2 is as it is, f of x0 y0 is as it is, plus as it is, f of x1 is as it is. This has become y1 of 1 instead of y1 of 0 in previous iteration. So what does it mean? It means instead of the previous value of y, I am going to calculate new value. So to calculate the new value, previous value I am considering here. Okay, so let us see what is that. Let us see how to solve this now. Okay, so this becomes equals to y0 plus h by 2 in bracket. Now from where this x0 y0 square root of x0 y0 has came, because this is f of x0 y0. F of, again I am not supposed to mention this, but still I will mention, f of xy in the problem is given is equals to x square root of x plus y, correct? So if this is the value of f of xy, then x0 y0 is going to become square root of x0 plus y0. Hence this has become square root of x0 y0 plus square root of x1 plus, instead of y1 it has become y1 raised to power 1, and y1 raised to power 1 is the first corrected value of y1. I will understand out of this. This is the first corrected value of y1. And what I am calculating right now, I am calculating the second corrected value of y1. y1 value was already calculated. Now I am trying to achieve the accuracy of 0.0001. In order to achieve that, first value of y1 was calculated, that was not accurate. So second value of y1 I am calculating. So if I put the values here in this equation, I will get y0 is equals to 2.2, then h is 0.1, x0 is 1, y0 is 2.2, x1 is 1.1, y1 of 1 is 2.38135. From where I have got this value? That I have calculated in previous iteration, where it was, here it was y1 of 1. So that same value I have used here. Okay, so if I put that value and if I solve this, I will get y1 of 2, means after correcting the value of y1 second time, I will get y1 is equals to 2.38273. Now this value I need to check whether it is correct or not. In order to check that, how I am going to check it is second corrected value of y1 minus first corrected value of y1, right? So that becomes 2.38273 minus previous value was 2.381351. So if I check this difference, it is not 3501, it is in magnitude. Okay, 2.38273 minus 2.38135. So its magnitude is taken. The difference comes to be 0.00138, which is still on higher side because I want the accuracy of 0.0001. So it is greater than 0.0001. Hence I need to make another correction. So if I am making another correction in the problem, I will be taking third iteration for correction. So that third iteration for correction when I take, I can say the formula y1 of 3, that is third correction in the value of y1. y1 of 3 is becoming equals to y0 plus h by 2 plus f of x0 y0 plus f of x1 y1 raised to power 2 y2, because third value I am calculating here. So earlier value which was calculated, that is y1 square, this value I need to take here, right? So the formula becomes y0 as it is, h by 2 as it is. This f of x0 y0 becomes equals to square root of x0 plus y0, this is known now how, plus square root of x1 plus y1. Instead of y1 it is now y1 square, and this y1 square value is known. So I will put all the values once again. I will get y0 is equals to 2.2, h is 0.1, so x0 is 1, y0 is 2.2, x1 is 1.1, and y1 square is equals to 2.38135. So if I put all these values, I will get y1 of 3 is equals to 2.38275. This is the new value of y1 I have got, that is the third value after making the third correction in the value of y1. y1 value we have already predicted, as I said, and we are making third correction. So after third correction this value we have got. Then checking the accuracy. So if we check the accuracy, you will find that accuracy will be checked with the help of the value we have got recently, that is third value after correction, minus the previous value of y1, that is y1 of 2. So if we consider that value here, magnitude of both the values is taken, and if you check this difference, that is coming to be 0.00002, which is definitely less than, this value is definitely less than 0.0001, which must be the accuracy that is mentioned in the problem, that this much accuracy we should mention. So hence the correct value of y1 is which one? The third value which we have just now calculated. This is the correct value of y1. Okay, so if this is a correct value of y1, this value we have calculated at x is equals to 1.1. How I come to know that? Because if I calculate x1, how much it is? x0 plus h into n. If I calculate that, I will get 1 plus 0.1, that is going to become 1.1. So 1.1 is the value of x. So at x is equals to 1.1, as you know, h is equals to step size, h is equals to step size, xn is not xn is equals to, or xr is equals to x plus h. So h is step size, and this will be x0 for starting. Okay, so x0 was 1 plus step size was 0.1, hence it has become 1.1. So at x is equals to 1.1, what is meaning of all this thing is, at x is equals to 1.1, value of y is 2.38275. This is value of y at x is equals to 1.1. This is not the end of the problem, because in the problem statement it is asked to calculate the value of y when x is equals to 1.2 with the step size of 0.1. See, if you look at the problem statement, it is asked to calculate value of y, that is yr, at x is equals to 1.2, and step size when we have calculated h, we have calculated it equals to 0.1. So with the help of this, I can say that I am moving with the step size of 0.1. x0 I have got 1. This is x0 value which is mentioned here. Then I have added 0.1, that is step size, to it. It has become 0.1 to it. It has become 1.1. At 1.1 I have calculated value of y after making corrections and everything. So I have got that equals to 2.38275. This is the correct value of y1 at x is equals to 1.1. But my work is to calculate value of y at x is equals to 1.2. So I am going to take one more iteration. Hence I can say, as xr is equals to 1.2 and x2 is equals to x0 plus 2h, the formula was xn is equals to x plus nh. This was the formula. So x value, or moreover it is x0 when I am writing it. Now this is correct. So if I am taking the step size of 0.1, new value of x, that is x2, so n has become equals to 2. x2 is equals to x0 which was 1 plus 2 into 0.1, that becomes 0.2. Hence new value of x will be 1.2, that is x2 equals to 1.2, and I am supposed to calculate value of y2. So to calculate value of y2, again we need to take the second iteration. Now this second iteration is not for the correction right now, but it is for the prediction. Once again we need to go for prediction. So that is why it is written here. Then it is considered yr is equals to y2 will be calculated in next iteration n2. Hence iteration 2, that is n is equals to 2. If you remember, I mentioned in this video only n is equals to 2, or n is representing the iteration for prediction and k is representing the iteration for correction. Okay, so n is for prediction formula we are going to use. Okay, so let us see. To predict that, the initial values which are already with us for prediction, x1 is equals to 1.1. this is the initial value. In earlier iteration we have got it here. Likewise y1 is equals to 0.38275, that also we have calculated here. So with these two values we are starting with the iteration, and the formula for iteration is y2 is equals to y1 plus h f of x1 y1. Now from where all these things are coming, or from where this formula has came, that is from Euler's modified method. This is the prediction formula of Euler's modified method, right? So that becomes equals to, earlier it was, see, when we have calculated y1, so for that value y1 0, this formula was y0 plus h into f of x0 y0. This was the formula there. Now this formula is modified as we are in second iteration. This has become 2, this has become 1, this has become 1, this has become 1. Hence the formula which is mentioned here is this much, this y2 is equals to y1 plus h into f of x1 y1, and this raised to power 0 is representing that this is not the corrected value, this is just the predicted value, because for correction I am going to take iterations, and likewise that value will be 1, 2, 3, iteration 1, iteration 2, iteration 3, that is value of y2. Okay, so friends, if we put the values in this formula for y1 h and f of x1 y1, then we will get as y1 is equals to 2.38275 plus h is 0.1, and as we know f of xy for this problem is equals to square root of x plus y. So if I want f of x1 y1, that is going to become square root of x1 plus y1. Hence it has become square root of x1 plus y1 shown here, right? Moving further, if we calculate this value after putting all, we'll get y2 is equals to 2.56937. Now this is the value of y2 without any correction, raised to power 0 I have written here, without any correction. So I need to check whether this is correct or not. If it is not correct, I need to correct it. So apply corrector's formula. Apply corrector formula. So if you apply corrector formula for value of y2, I will take first iteration. In the first iteration itself, I have written y2 raised to power 1 because this is the first iteration. So k has become equals to 1. K is equals to 1 here. Okay. So if I take k is equals to 1, the formula becomes y2 raised to power 1 is equals to y1 plus h by 2 f of x1 y1 plus f of x2 y2 raised to power 0. I hope now this part, as it is already done in the same discussion, so this you have understood. This is value of y2 without any correction, which was calculated here, okay, in the prediction formula. So next work is to put the values, all the values. So we'll put the value of y1, h is equals to 0.1, x1 is 1.1, y1 is 2.38275, x2 is 1.2, and y2 raised to power 0 will be 2.56937. So if we calculate y1, that is, if we calculate y2 raised to power 1, that is value of y2 after first correction, is equals to 2.5777925 shown here. Then the next work is to calculate the accuracy. How to calculate the accuracy? New value of y2 minus the previous value of y2. Previous value of y2 will be represented here is y2 raised to power 0. So I will do magnitude of y2 raised to power 1 minus magnitude of y2 raised to power 0. I will get the accuracy here with this y2 raised to power 1 minus y2 raised to power 0. If you put the values, that comes to be 0.095863, which is greater than 0.0001. If the accuracy we have calculated is greater than the accuracy which is required, our work is to take another iteration for correction. So I will take the iteration 2. So my k value becomes equals to 2 as it is second iteration. Hence the formula is going to become y2 square y2 raised to power 2. This is representing that this is second iteration, means second time we are correcting the value of y2. So if we do that again, the formula for it becomes, this formula becomes y1 as this has 2, as k is equals to 2, this value becomes y1 plus h by 2 f of x1 y1 plus f of x2 y2 raised to power minus 1, right? So this formula, if you compare it with the previous one, if you look at these two formulas, see which two I am talking about, y2 raised to power 1 and y2 raised to power 2. If these two formula we compare, what is the difference between these two? There is only one difference. See, y1 is same, then h by 2 is same, f of x1 y1 f of x1 y1 is same, plus f of x2 is same, instead of y2 of 0, it has become y2 of 1, y2 raised to power 1. It means this value is taken here. I hope you will understand this, right? So if I put the values in this equation, again I will get second iteration. In second iteration, y2 of 2, y2 raised to power 2 is equals to y1 plus h by 2, f of x1 y1 becomes square root of x1 plus y1 plus f of x2 y2 becomes square root of x2 plus y2 raised to power 1. y2 raised to power 1 is the value which is already calculated here. So if we put all the values here in this equation, if I put all the values of y1, x2, x1, y1, then x2, y2 raised to power 1, and if we solve this, you will get finally y2 of 2 is equals to 2.5779009. Once we got the value of y, the next work is to calculate the accuracy, and accuracy no doubt is calculated with taking the difference of two values of y, recent value and the previous value. So I will take recent value y2 of 2 after second correction minus y2 of 1. So if you put these two values here, magnitude of which comes to be, if 2.573 this value and this one, if we take the subtraction between these two, answer comes 0.001241. This is the difference, means this is a accuracy which is definitely greater than 0.001. Hence I need to take the third iteration. So now k becomes equals to 3, and I'm going to take the third iteration. See, if you observe, this is just a repetition of same work we are doing, and in every term we are trying to calculate the better value for y, that is we are trying to reach towards the actual or the correct value of y. Okay, and that is why we are taking the iterations. Okay, so in third iteration when we go, we have taken k is equals to 3 as mentioned here. So value of y2 in third iteration of correction, it becomes equals to y1 plus h by 2 f of x1 y1 plus f of x2. This value is only change. What is that? This value will be now y2 raised to power 2, means the previous value of y2 which you have calculated in previous iteration, that value I am going to take it here, put it here instead of that y2. I am going to put y2 raised to power 2. So next work is to just put the values of all y1 h, then f of x1 y1. For this problem it is square root of x plus y. If you want x1 y1, that becomes x1 y1 here, square root of x1 plus y1. Again this value, second value, f of x2 comma y2 square is going to become square root of x2 plus y2 square. Then putting the values of each term, will get y2 of 3 is equals to 2.573 If we calculate the accuracy here, the accuracy becomes equals to the value of y2 in third iteration minus value of y2 in second iteration, its magnitude part. So if we put those two values here, we'll get the accuracy is equals to 0.000016, which is definitely less than 0.0001. That is the value mentioned in the problem statement, that you need to have the accuracy less than, or you need to maintain the accuracy of 0.0001. If accuracy is less than, or the difference is less than 0.001, that is if the difference between the two values is less than this, we can say the accuracy is maintained. Hence correct value of y2 will be the value which we have just now calculated, that is this value. So y2 is equals to 2.573183. so yr, that is equals to yr at x is equals to xr. It means when x becomes equals to 1.2 x, that is x2, that time y2 is equals to 2.573183. See friends, this was that way was the heavy problem where there are n number of iterations, means actually the iterations for prediction were only 2, but for correction every time you have taken 3 iterations. So total 6 iterations we have performed for correction and 2 iterations for predictions. So this problem that way is lengthy. I have taken this lengthy problem so that you will understand the easier problems at your own. You can prepare it at your own with some easier problems where the number of iterations are less. And I hope this session will help you in understanding the Euler's modified method to solve the first order ordinary differential equations. So this was predictor corrector formulas we have used, and this method I hope will be useful for you to prepare for your examinations. If you understood the discussion which we did here, or if you understood the things which I have explained, I request you to please like the video and please subscribe to this channel for more videos on this. Thank you.